Welcome everyone. Let's begin our lesson for today by going over the learning goals and success criteria. First, what are we learning? We're learning how to determine how a function behaves around given values and how to determine when and where a whole or asymptote occurs. How are we learning it? Through the function descriptions part 1 notes and the function descriptions part 1 assignment. When can we use this information? To recognize trends and graphs to determine the trends in the stock market. How do you know you learned it? By getting a score of 4 on the function descriptions part 1 assignment. Now let's take a look at our agenda for today. We will begin by going over the learning goals and success criteria. While we do that, you'll fill out your Get It Started. Once you've completed your Get It Started, we'll go over it together and answer any questions that you may have. After that, we'll go over the function descriptions part 1 notes, and then I'll give you time to complete the function descriptions part 1 assignment on Desmos and Google Sheets. Once you've completed your assignment, we'll go over it together and answer any questions that you may have. At the end of class, we'll go back over our learning goals and success criteria while you fill out your Before You Go. Your only homework for tonight is to continue working on the reasoning with features of function study guide and any incomplete assignments that you may have. Let's take a look now at the function descriptions part 1 notes. The notes begin with the learning goals and success criteria. Now, what is an asymptote and a whole? An asymptote is a line that the graph approaches but never crosses. So, an example of this would be 1 over x minus 1. And we can say that it has an asymptote at x equals 1 because anytime the denominator equals 0, that's a spot where it would be undefined because now we're dividing by 0. And remember from closure, if anytime we divide by 0, we have an undefined value. So it's undefined at this point, so we create an asymptote there. Now a whole is a point that is not on the graph and because it can be factored out of both the top and bottom. So it's where the graph continues on and then stops for a second and then continues on after that. So an example of this would be x plus 1 over x plus 1 times x minus 1. And we'd say it has a whole at x equals negative 1 because this can be factored out of both the top and bottom. And then we would solve that for x and we get x equals negative 1. So how does this look graphically? An asymptote looks like this. So we have our graph here, and it gets really close to negative 2, but it stops and doesn't actually touch it. So it just keeps going up and getting really high here, but it will never actually cross this line of negative 2. Same thing here. It gets really close here to negative 2, but never actually crosses it. Now a whole, an example of that would look like this. So we have our parabola here, and then just at this one spot, it's missing. So the graph continues and does cross, it just has a point there where it doesn't actually exist. So how does an asymptote or whole affect the domain? Well, we can see here that our graph goes to here, so it goes from negative infinity, but then when it gets to negative 2, it stops continuing. It stops and has an upper boundary of negative 2. And then it picks back up again. So here we go from infinity, and when we work back this way, we go to negative 2. So it has a domain of negative infinity to negative 2, and a domain of negative 2 to positive infinity. So let's talk now about how we can solve for asymptotes. Well, if we're given a function like this, f of x is equal to 1 over x minus 1. What we need to do is we need to recognize where the vertical asymptotes occur. And they occur when the denominator is equal to 0. We know this, again, because when the denominator is equal to 0, the function would be undefined. So we set the denominator equal to 0. So x minus 1 is equal to 0, and solve. We add 1 to both sides, and we get x equals 1. So this is the location of our vertical asymptote. Now, how do we find wholes? We find wholes when a common factor of x exists in both the numerator and denominator. So for instance, in this case we have x plus 1 over x minus 1 times x plus 1. What we should notice is we have an x plus 1 in both the numerator and denominator, so we could cancel those out. When we cancel those out, we gain a whole and lose an asymptote. To find our whole then, we just set that equal to 0. So x plus 1, we set it equal to 0. Subtract 1 from both sides and we get x minus 1. So that's where my whole occurs. Now there's a video here that shows you how to graph functions in Desmos. So go ahead and watch that video. Let's take a look now at how we can use Desmos to graph any function. So in order to do that, we're going to go to desmos.com and go to Graphing Calculator. And here we can type in an equation. So let's say that we have a linear function, which is y equals 2x minus 5. And notice it graphs it for us. It creates this graph here. We can type in any kind of function. We can do an exponential. Y equals 2 to the x power minus 5. That's what it would look like there. We can type in a quadratic. Y equals 2x squared minus 5. And see exactly what that one looks like. We can do trig functions. So y equals sine of 2x. And that's what it would look like. We could do logs. Y equals log 2x. And see exactly what it looks like. So we can graph any one of these kinds of functions and it will do it for us in Desmos. If there's ever any difficulties with what you're trying to do, so let's say I'm trying to do a squared term, so y equals x squared, and you're not sure how to do that, this little keypad here will click out, and now I can change it to be squared. I can change it to be any exponent here, so I can click on this and make it to the 6th power or whatever I want it to be. So you can use this any way you want, and this is how we can use Desmos to graph any function. Now what is end behavior? End behavior is the behavior of the graph as it approaches positive infinity or negative infinity. So end behavior can be written as this: as x approaches some value, and it doesn't always have to be infinity or negative infinity, it could be some value, it could be the asymptote. So as it approaches, and this negative sign means that it's approaching from the left side, so as it gets close to that point from the left side, y is approaching some value. The other version would be as x approaches that point from the right side, then y is approaching something. So an example of this would be here. So we have our function here, and we have a vertical asymptote here at -2. So we're going to say then, as x approaches -2 from the left side, what is y doing? Well, as we get closer to -2 from the left side, we can see that y is increasing exponentially. So y is approaching infinity. So as x approaches -2 from the left side, y is approaching infinity. Now, if we look at as x approaches -2 from the positive side, so from here, so from the right side, so as we get closer to -2, what is happening with the graph? Well, we can see it's going up and up and up, so y is also approaching infinity. This is how we can describe end behaviors. Now there's a video here that shows you how you can use a spreadsheet to find values. So go ahead and watch that video now. Let's take a look now at how we can use the spreadsheet to answer questions. So on this one, the formulas are already given for you, so you just have to copy and paste these in. So this would be for question 2A on the function descriptions part 1 assignment. So I'm going to go ahead and copy this here. So I copy it. I'm going to come down and put equals and then paste it. And it should ask if you want to autofill. Go ahead and click the check mark. So now we have all of our values here. Now we're going to do it for the denominator as well. So I'm going to go ahead and copy this, come down, put equals, and then paste it. Again, it asks if I want to autofill. Click the check mark. And then lastly, we're going to go ahead and put the numerator over the denominator. So we're going to copy this, put equals, and then paste it. It asks if we want to autofill. We click yes. And notice it appears in red. These would be your answers. So these are the answers that you will put into your Desmos activity. Once you're done with this one, we'll go to the next question and do the same thing with each of these columns. So I'll copy it, put equals and paste, and then autofill. Copy, equals, paste, and then autofill. And you'll do that for each of these questions and then move those answers into Desmos. So this is how you can use a spreadsheet to solve math problems. Let's talk now about how to sign in to Desmos to complete your work. So what we're going to do is you're going to click on the link to go to the assignment, and it should take you to a page that looks kind of like this. And right here where it says sign in with Google, we're going to click there. And it's going to pop up with our email accounts. You're going to click on your school email account, and it should already have you logged in because you should have already been logged in using Google Classroom. From there, I'm just going to click start the activity, and it will take me into the assignment and allow me to begin. So that's how you will log into Desmos using Google. Let's take a look now at the function descriptions part 1 assignment. The assignment begins with the learning goals and success criteria. If we scroll down, there's a link here to take you to the Desmos activity. Go ahead and click on that link, and it should take you to a page that looks like this. We'll go ahead and click start the activity. Now the assignment begins with the learning goals and success criteria as well. We'll go ahead and click next. Now for this one it says, for each of the graphs shown below, describe the behavior of the functions around the indicated value in words and with symbols. So we're just going to go ahead and do this with words. So here, as the graph approaches, and we're looking at -2, so we can say as the graph approaches -2 from the left side, the graph is going up, so y increases infinitely. Then on the other side, we'd say as the graph approaches -2 from the right side, y, so now we're going this way, y is going up infinitely as well, increases infinitely. So that's how we say it in words. Then over here, we're going to write it as symbols. So it says as x approaches, and we have negative infinity and positive infinity, we need to change that to be our value, which is 2, -2 here. So as x approaches -2 and -2, and we need this to be positive. So we're going to hit Shift 6, and that allows us to go up. Now we can do the negative sign, and do it again here, Shift 6, positive sign there. So as x approaches -2 from the left, we said y was approaching infinity. So we just type in the word infinity, and there we go. And we're going to do the same thing here. As it approaches from the positive side, from the right side, we're going to infinity as well. So we type in infinity. Then we hit submit. Then we click next and go on to the next one. So same thing here, but now we're approaching pi over 2. So as the graph approaches pi over 2 from the left side, y is decreasing infinitely, right? It's going down. Decreases infinitely. And then we look at the right side. So as x approaches here, so we'd say as the graph approaches pi over 2 from the right side, y is now increasing infinitely. Okay, and then we go ahead and put that into symbols. So here we're going to change this to say pi, pi, changes it to pi over 2. And then we want to hold Shift 6 to create our exponent from the left side. And then we do it again. Pi over 2, Shift 6 from the positive side now. So as it approaches from the left side, we're approaching negative infinity. And over here, as we get closer to pi over 2 from the right side, we're approaching infinity, so we say infinity. And you'll do that for each of these. Then when you get to slide 6, you're going to use your spreadsheet to help fill in this table. So, and then you're going to decide whether it's a whole or asymptote. Well, we noticed that there's nothing that can be factored out of this, so it would be an asymptote. And then you'll use your table to fill this part in. And then you're going to state as we approach, in this case it's going to be -1, where it's undefined, what is happening. So what is y doing? So as we approach -1 from the left side, y should be approaching something. And as we approach from the right side, what is happening? So you'll just state that. You'll do the same thing for this one here, and this one as well. So you'll do that for each of these four using your table. Decide whether it's a whole or asymptote. And then describe the end behavior. And then once you're done with this, you'll go ahead and go back to your Google form and click Next. This will take you to your Before You Go. Go ahead and fill out your Before You Go and then submit your work on Google Classroom.